Hello again. So we have just finished up talking about a whole unit on bonding, on ionic bonds, metallic bonds, and covalent bonds. And now what we're moving on to is our new unit, which is all on chemical reactions. So now we're taking those compounds that we now know a lot about, and we're looking at what happens when those compounds combine. So the first section is just describing chemical reactions, and eventually we're going to learn how to balance chemical reactions, which is a skill that you started to learn in middle school and we will just continue with here. So what is a chemical reaction? Well, remember, we looked at chemical reactions in relation to physical reactions. Physical reactions or physical changes is where the properties may change, but the actual chemical substance stays the same. When we boil water, for example, and we take water from a liquid to a gas, it's still the water molecule. We haven't broken any bonds. We haven't made any new bonds. A chemical reaction or chemical change is one in which bonds are going to be broken. So a chemical reaction is a reaction where a new substance is formed. Bonds can be broken, bonds can be made, or often both things happen. First, the old bonds are broken and then new bonds are formed. And when we looked at this earlier in the year, we looked at 5 things that we could think of as evidence for a chemical reaction. It's not always definitely means that a chemical reaction has taken place, but sometimes it's hard to know, and this can help us. We looked at this with an acronym that city girls love their phones, and that can help us understand or remember the 5 pieces of evidence for a chemical reaction. The C stands for color change. G stands for a gas is formed. L stands for light. T stands for a temperature change. And P stands for a precipitate. So a precipitate, this was the new one for us, is a solid product that is formed when 2 aqueous solutions mix together. We're going to look a whole lot at this last one in this chapter. And so these are some of the symbols that you might find in a chemical reaction. The plus sign separates out 2 reactants and 2 products. The arrow is sometimes translated as the word yields, and it separates the reactants from the products. This may be a new one. It's the equilibrium symbol. It means that reactants are making products and products are decomposing to make reactants, and those 2 things are happening at the same rate. Sometimes you will see after a substance in parentheses an S, an L, or a G. That means solid or liquid or gas. Sometimes you may see AQ. AQ is a new one. That means aqueous. That means dissolved in water. Over the arrow, you might see a delta or the word heat. That means that heat was needed to be added in order to get this reaction started. Or you may see a chemical symbol, like especially for an element, especially for a transition metal element. Those are oftentimes catalysts. So because catalysts are not reactants or products, they're not used up in the reaction, we don't put them on either side. We sort of put them right in the middle there. And then this graphic here just helps us to understand what's going on in a typical chemical reaction. We see that we have the reactant molecules here, and what needs to happen is those bonds need to be broken. And we looked at this last chapter that energy or enthalpy needs to be added in order to make that happen. And then we have very unstable elements without their full octet up there. And then new bonds come together, right? And these are the new bonds that are formed. And wherever we make bonds, energy is released. And overall, if we look at the difference between the energy in and the energy out, that could tell us whether a reaction was endothermic or exothermic. And so here's just like a description of a chemical reaction. A chemical reaction takes place. Solid iron is added to aqueous hydrochloric acid and reacts to form hydrogen gas and aqueous iron chloride. For every mole of iron, 2 moles of hydrochloric acid that react, 87.9 kilojoules of heat is given off. And so you can see in this, it tells us solid iron is added to aqueous hydrochloric acid. And here's the solid iron. You can see that in parentheses S. Here's the aqueous hydrochloric acid. And then it says reacts to form. So that is what's telling us about the arrow, that there's an arrow there. And then hydrogen gas. There's the symbol for hydrogen gas as one of the products. Aqueous iron chloride. There's aqueous iron chloride right there. And then the second part tells us for every mole of iron and 2 moles of hydrochloric acid that react, 87.9 kilojoules of energy is given off. And so there's that delta H. It's a negative number. That's the given off part is why that's a negative. And there's the 87.9. And then here's that same idea of a chemical reaction, but sort of looking at it at more of a particulate level, looking at the actual particles that are involved. So first you have this iron, solid iron, and then it's in this mixture of HCl. And HCl is a strong acid, which means that it's completely dissociated in water. So see how they're separate. And then what you notice is when we put the iron in, hydrogen gas bubbles begin to form. Because what's happening here is the iron, and we will learn this a little later on, is actually going to be giving its electrons to the hydrogen ions, making a molecule of hydrogen gas. And now the iron, that iron with all of its electrons, as it is over here, see how it doesn't have a charge? Iron with all of its electrons is not soluble in water. But here's iron with a charge, 2+, meaning it's lost 2 electrons, and it is dissolved in the water. So this is, just an overview of what happens in a particular chemical reaction.